Hello students, today we are going to discuss the physics problems of the RENEET 2026. If you look at the questions of the physics this year, it appears to be on the tougher side, more difficulties there compared to the previous year questions, right. And that is the main reason most of students will not be scoring very good or high marks in this physics section, right. Anyone who is scoring around 80, more than 80 will be considered a good marks, but you can also score more than 131, 140 if you have worked hard in the physics. The solution of this video is going to be little lengthy because I am going to go in very detail of this solution. So, you will be getting a detailed solution, right, and I will be also discussing the concepts which revolve around the questions, right. So, if you look at the questions of this year, right, starting from the question 1 to 45, I found only 2 or 3 questions which were very straightforward. Rest of the questions were requiring a deep concepts, sometimes more mathematical calculations. And also if you try to read this question, in spite that people have created a lakhs of the questions in the physics, I would appreciate that this time the question setters have done a very great job to making the question a bit unique. Making the question unique in the physics nowadays is silenced because already people have thought a lot and had prepared, created a lot of questions, and that makes this paper a little unique, right. So, there is always some element which asks us to appreciate, or at least make us appreciate the question, right. So, if you go through the entire video section, there is a lot of learning going to happen. Let us try to solve these questions, right. Before we solve, I'll just try to give you a disclaimer that every question, now before you jump into the solution, every question you should read carefully and you should develop a good sense about the question. Then only watch the solution, right? Because I'm not going to read question for you. I want you to pause the video, read the questions, and then look at the solution, right? So let's start with the question number 1. I hope that you have read the question. This question appears to be coming from the kinetic theory of gases. In kinetic theory of gases, we discuss with a few quantities. One is called a degree of freedom, another is called a Cp by Cv of the ideal gases, and then there is a relation between Cp upon Cv and the degree of freedom of the gas. You know that if you look at the gases, they can be monoatomic, diatomic, or linear polyatomic, as well as non-linear polyatomic, and depending on the nature of the gases, they can possess a different degree of freedom, right. Most of the time in the classes we don't discuss the degree of freedom associated with the vibrational mode, right. But if you look at this question, it appears that they are trying to check with your understanding regarding degree of freedom with the vibration mode, right. Now, no matter whether the vibrational mode is present or not in a given gas, this relation holds true, which says that Cp upon Cv equals 1 plus 2 divided by total degree of freedom. I am using F naught. Generally we use F, but there is already F sitting here in the questions. I don't want to get confused with both the F's. So let us distinguish it from this F. So this is the equation, y equals 1 plus 2 by F naught, right. In the question, Cp upon Cv is given. This is 8 by 7. So 8 by 7 equals 1 plus 2 divided by F naught, which gives you 2 by F naught equals 8 by 7 minus 1, which will become 1 by 7. Solve it, you will find F naught equals 14. So total degree of freedom, F naught equals 14, right. But in the question, you are being asked to find the degree of freedom associated with only vibrational mode, right. So if you look at the total degree of freedom of any gas, that will be a degree of freedom due to translational motion plus a degree of freedom due to rotational motion plus degree of freedom due to vibrational motion, right. Now in the question it is given that due to translation it is possessing 3, due to rotation it is possessing 3, and the number of modes of the vibration, can you see the F is the number of vibrational modes. So if any gas molecule has F number of vibrational mode, then it possesses 2F number of degree of freedom. Why? I will explain it later after this solution. If you solve this, then you will get 8 equals 2F, which makes degree of freedom associated with the vibrational mode will be 4. That should be your answer. 4 is the correct answer. This is your answer. Now the question comes, why 2F? Right. Now to understand this 2F, I will have to take you to the concept of monoatomic, diatomic and polyatomic. If you look at the gases, it can be monoatomic, it can be diatomic, sharing some bond with the neighboring atoms, or it can be polyatomic, sharing again some bond with the neighboring atoms. Some bond is there. Right. If the gas is monoatomic, there is no concept of vibrational mode. Right. Vibration comes because of the bonding. Right. The two atoms, when they are sharing their bonds, they can vibrate, right? Or three atoms can vibrate due to their bonds. Now, one atom does not have any concept of the vibration, so it is not applied for the atoms of the monoatomic mix. But if you have the diatomic and if you try to increase the temperature to a very high level, then they start vibrating, oscillating, with a very high frequency, and at that time, you don't ignore their energy associated with the vibrational motion. Right? So we can model this as there are two masses connected with a spring. The bond can act as a spring. When this is made to oscillate, you can expect the energy associated or due to motion in the form of kinetic energy, plus there will be due to position, electrostatic forces, interaction, you can expect potential energy. Right? So when there is a vibration of a diatomic, there will be energy associated due to motion, kinetic, and due to relative position, potential energy. It means if there is a one mode of vibration, you can expect two form of the energy. One is kinetic, another is potential. On an average, they are equal. Right? For every oscillation, the kinetic energy average value is same as potential energy average value. So there will be 2 degree of freedom associated with the vibration. Similarly, if you have polyatomic, again they are sharing bond, so you can expect there are 3 springs here, right? So you can expect one mode of oscillation between these two, one mode between these two, and another mode between these. So you can expect 3 modes of vibration. That makes 6 degree of freedom associated with vibration. So they will possess 6 degree of freedom only due to vibration. This will possess 2 degree of freedom only due to vibration, right? I hope that it makes sense to you that when there is one mode of vibration, then there are 2 degree of freedom associated with it, right? So you can solve this question. Let us move to the next question. Right. The next question is regarding this measurement with the help of the vernier caliper, right? And if you look at this, in the question, this diagram was not given. Just I have taken it to help you understand some, concept regarding zero error, right? So the question says that this vernier caliper was used to measure something, and it measured the length to be 1 centimeter, right? So whenever you use a vernier caliper, the vernier caliper can either be defective or it can be authentic, right? The defect arises when you try to bring the two jaws in contact and the zero of this main scale does not coincide with the zero of this vernier scale. The movable scale is known as vernier scale, the fixed scale is known as main scale, right? So bring these two jaws in contact and see if these two zeros are coinciding or not. If these two zeros coinciding, it means you have the perfect instrument to measure. It is not going to give you any kind of zero error, right? But if the two jaws are brought in contact and these two zeros of the main and the vernier do not coincide, you can expect zero error, right? So when they do not coincide, there are two cases. Either the zero of the vernier will go left, or the zero of the vernier will go right of the zero of the main, right? Can you see that if the zero of the vernier remains right of the zero of the main when the two jaws are in contact, so you are measuring nothing, but it is already giving you some reading. It means that it reads more than the original line, right? And if the zero goes left, it means it is measuring less than the original length, right? But in this question, you can see that the zero is to the left. It means that the actual value should be more than what it is reading, right? So it is reading 1 centimeter. So you should expect the original length to be more than 1 centimeter, because whenever this zero goes left, it gives you the negative zero error. Negative zero error. Negative zero error means that the actual value is always greater than the measured value, right? So your answer must be greater than that 1 centimeter. That gives you the idea that this should be your correct answer. If you don't do any calculation, this is where you will land, right? But if you do the calculation to find it, so you need the least count to find the zero error, because if you can add the zero error in the 1 centimeter, you can get what the actual value is, right? So how to find the zero error? So zero error, if the zero error is negative, this is equal to a number of divisions on the vernier scale minus which vernier scale is coinciding with the main. So which one is coinciding? The fourth one. So 10 minus 4 into least count, right? That makes 6 into least count. Now read the question. Do we have sufficient information to calculate the least count? Or to me it appears no, because they only have given that this division length is 1 millimeter, right, on the main scale, and the vernier scale has 10 divisions, right? So from there it is not sufficient to calculate the least count. But if you make this assumption, which is generally for the vernier caliper available in market, that n minus 1 main scale division coincide with n vernier scale division, in that case you will find that least count is nothing but 1 divided by n into 1 main scale division, right? So this assumption you need to take into account to get to the result. So this will become 6 into the least count value is how much? 1 divided by 10 millimeter. That makes 0.06 centimeter. Right? So if you add this to 1 centimeter, you are going to get the original. It appears that none of the options are available, right? So your answer should have been 1.06 centimeter, but there is 1.04. If you mark this, I don't know, you should get the answer, but actual answer is missing from the options. Let us move to the next question. Now, this question is from the semiconductor devices, right? So you have 3 identical PN junction diodes, all are identical, right? And then you have a battery and you are connected like this. If you read the question carefully, or if you observe the diagram, you find that this is open. This is open means it is having the original depletion region width. This is in the forward bias condition. Can you see that this positive terminal is towards the P and this is negative terminal. So this is forward biased. This is not biased, and this is a reverse biased. Right? So in forward bias condition, the width of the depletion region decreases. In the reverse bias condition, the width of the depletion region increases, and that's why in this case the width of the depletion region should be maximum, followed by this, which is having the original value, and this has decreased. So if you look at the order, it appears W3 should be greater than W2 should be greater than. That's the answer. Let's move to the next one. Okay. So this is a spring mass problem, right? They are saying that it is performing simple harmonic oscillation, right, or motion, The mass of the particle is m kg and the spring constant is k. At a given instant, the extension of the spring is x meter and the speed is v, right? And if you try to plot this on xv plane, you are going to get a v versus x curve as a circle, then the correct option is, right? So in the simple harmonic motion, let's say spring mass system, this is the, let's say, natural length. Let's say this is mean position, x is equal to 0, and if you extend it by x, and it gains some speed v, right? So some potential energy, some kinetic energy. In the SHM, you know that they are related with each other. We know that v square is nothing but omega square into a square minus x square, right? This is how you can find the relation. So if you solve this, you'll find that v square equals omega square a square minus omega square x square, which gives you v square plus omega square x square is nothing but omega square a square. This is the relation, right? If you treat this as a y and if you treat the entire term this as a x, then y x square plus x square is equal to r square is the equation of circle, right? So the coefficient of y square and the coefficient of x square must be same when it represents the circle. So since the graph is circle, and that's why omega square must be equal to how much? 1, so that it meets the coefficient of this v square. And you know that omega square is nothing but k by m, which is nothing but 1, and which makes k equals m. Then look at the option. The option 1 is matched. So moving to the next question, question number 5. The question appears to be coming from the electromagnetic wave, where the equation of the electric field is given, and then also the dielectric constant of the medium is given, right? And you have to check which one of the given option is incorrect, right? You have to choose the incorrect option. Just to get an idea about the electromagnetic wave or any kind of wave equation. So the wave equation will always contain the spatial coordinates like x, y and z. If it is a unidirectional wave, it will have either x, y or z. If it is multi-dimensional wave, it can have all the three coordinates like x, y as well as z, right? But for you, most of the time we discuss the wave traveling in a single direction. That's why you always get to see either x, y or z in the equation. And also the wave equation will contain, apart from this spatial coordinates, the time as well, right? So in the function there should be a spatial coordinates as well as time. So if you look at the wave equation, it will be in the form of this. Every wave equation is always in this form, right? And from this equation, this form, if you want to check the direction of propagation, look at the coefficient of t, which is called angular frequency omega, and coefficient of x, which is angular wave number. Take their ratios, the coefficient of t and the coefficient of x, and if they come to be negative, the wave will be traveling along positive direction, and if they come to be positive, the wave will be traveling along a negative direction, right? This k and the omega will be the magnitude of b and a, because these quantities cannot be negative, right? But the ratio b by a can be negative. So if it is negative, you should know that the wave is traveling along positive direction. Now look here. In this case, what is omega? 2 pi into 10 to the power 6. What is the angular wave number? K already given, right? So the ratio is the coefficient of t divided by coefficient of z coming to be negative. That's why you can say that the wave is moving along a positive z axis. So the direction of propagation of the electromagnetic wave is along positive z. So this is correct, but you have to choose incorrect option, right? What is the speed of the electromagnetic wave inside the medium, right? You know that in any medium, the speed of the electromagnetic wave v is nothing but 1 divided by under root permeability into permittivity, right? If you can find the permittivity and permeability, you can get the answer, right? Now, if you want to find the V, which gives you V is nothing but 1 divided by mu is nothing but mu r into mu naught, right? Because you know that mu r is nothing but mu divided by mu naught. And similarly, epsilon is nothing but epsilon r into epsilon. We can see we have the data regarding epsilon r, but we don't have data regarding relative permeability. But they are saying that it is a lossless dielectric medium. This generally gives us the idea that it should be equal to 1 non-magnetic medium should be there, and that's why you can write V is nothing but 1 divided by under root epsilon r into mu naught into epsilon. 1 by under root mu naught into epsilon naught is going to give you the speed of light in vacuum, and that's why you can write V is nothing but 1 by under root epsilon r into c. Under root epsilon r will come to be 3, so 1 by 3 into c is 3 into 10 to the power 8, that makes 10 to the power 8 meter per second. That's the speed of the wave in the given dielectric medium. We also know that in a given medium, speed is nothing but lambda in the medium, frequency in the. Okay. So we can write 10 to the power 8 is nothing but lambda in the medium into frequency. Frequency is nothing but omega upon 2 pi, which gives you 10 to the power 8 is nothing but lambda into, look at the value of omega. Omega is the coefficient of t in the equation, which is 2 pi into 10 to the power 6. 2 pi into 10 to the power 6 divided by 2 pi will get cancelled. That gives lambda is nothing but 100 a meter. So wavelength would be 100 meter, right? And if you want to find the B in the medium, so B naught in the medium is nothing but E naught in the medium divided by speed in, right? So while writing the equation of this magnetic wave, you can use the B naught as E naught upon V, right? So coming back to the options, the wavelength of the electromagnetic wave in the medium is 300. We saw that it is wrong, so this is incorrect, right? The magnetic field is given by this, so this is also incorrect because we need here E naught, not B naught, so this is also incorrect. The speed of the electromagnetic wave inside the medium is that is correct, right? So in this question, we can see there are two options which appear to be wrong. Right, this appears to be typo. We don't know what it is, but they both are wrong, right? I don't know. You can get the bonus marks if you challenge it, right? Let us move to the next question now. Okay, question number 6. So a frictionless circular wire of unit radius is fixed on the horizontal plane. Two particles of unit mass start simultaneously from point A. So from point A, there are two objects which start moving, right? Both move in the opposite sense, right? So if they start moving in the opposite sense, let's say this is the tangential speed. So when theta equals pi by 2 initially, theta is equal to pi by 2, their linear momentum will get cancelled because it's vector quantity, equal and opposite will get cancelled. So at theta is equal to pi by 2, you should expect it to be 0. So theta is equal to pi by 2, 0. No. So this is your correct answer. You can write this. After that, again it will become 0 when the angle becomes minus pi by 2. Minus pi by 2. When they come here, one is moving towards this, another is moving towards it. Again it will be 0. So this appears, the correct answer. Let us move to the next question. Again, this is a graphical question. So there is an experiment and they are asking the number of scattered alpha particles is plotted as a function of scattered angle theta. Which one of the following option represents the correct plot? Again, they have picked these questions to a very nuance of the Rutherford, alpha scattering experiment, which we generally avoid teaching the students because the number of particles scattered at angle theta is directly proportional to 1 by sine to the power 4 theta by 2. This is the expression that comes. And this is not the actual expression, only proportionality I am showing it. So look which is going to fulfill this equation. So when theta tends to 0, n of theta should tend to infinity. 0, this is not correct. Should tend to infinity, not correct. Not correct. This is the correct answer. Okay. The only thing that you should be knowing that n of theta is directly proportional to 1 by sine to the power 4 theta y. This question. This is from the optics, right? So there are 3 optical media, the vacuum. This is having refractive index 1.25 and this is having 1.5. The object is directly kept here, right? And then they are saying that the medium Q having a thickness of 5 centimeter, right, is placed between the extended media P and R. So this is the P and this medium is R as shown in the figure. An object O is placed at the center, so exactly 2.5 from this and 2.5 from this it is placed, right? If viewed from the medium P1 near the downward direction, the apparent depth is H1. So if you try to look at this from the air, the height is H1, right? And for the similar observation from medium R, the apparent depth is H2. From here, if you try to observe this from the here, this appear to be a distance H2 from the eye, right? So when you try to study the normal view, right, from one optical medium to another optical medium, so whenever you look at the optically denser medium, the objects appear a little nearer than the actual position, right? And if you try to look at the object from denser to rarer medium, it appears little further away from its actual position. So you can say that H1 must be less than what? H2, because viewer is in the rarer, object is in the denser, it will appear little shifted up. And from here, if you try to look denser to rarer, it will again appear little shifted. Let us try to solve it. So we can write H1 is nothing but H naught divided by a relative refractive index, that is 1.25 divided by 1. You can directly write H naught divided by 1.25 if you are looking from the air, right? So H naught is 2.5 divided by 1.25. This is coming to 2. Okay. And if you try to look at the H2, H2 is nothing but since it is going to be appear more than the actual height, so you'll be writing relative refractive index, that is 1.5 divided by 1.25 into what is the height? 2.5 centimeter. So this will come in 3. Right. So from here it appears at 2, from here it appears at 3, right? So what is the question? Modulus of H1 minus H2, and that's why modulus of H1 minus H2 will become 2 minus 3 modulus, that is 1. So your answer should be 1. Now, had both sides, let's say upper and this P and this R medium had been the same, then your answer would have been 0, because from here or here, both optical media are same. That's why the apparent position will be at the same distance, that will make 0. But this is denser, that's why you are getting different than 0 answer. The next question. This is related with this dimensional formula. So sigma S, kV and D represents the Stefan-Boltzmann constant, right? Wiens displacement law constant and this Stefan constant, okay? Then you have to find the dimensional formula of this. So whenever you have to write the dimensional formula of any physical quantity in the science, try to look at any equation, mainly simpler equation which involves that physical quantity. So you know that from the radiation law, that power P is nothing but sigma EA into T to the power 4. This is the formula, radiation, right? This is the rate at which the heat is getting radiated from a surface of surface area A, temperature T, emissivity E, and this Stephen Boltzmann constant sigma is this. So from here, if you try to find the dimension of sigma, it will coming to be dimension of power divided by dimension of emissivity, dimension of area, dimension of temperature to the power 4. Power is energy upon time, so this will become NL2T minus 3 divided by emissivity is the ratio of the same physical quantity, so no dimensional formula. Area again L square and temperature Kelvin K to the power 4. That makes the dimensional formula of sigma equals M T to the power, this is minus 2, so M minus 2, M L to the power minus 4, T to the power minus 3, K to the power minus 4. You also know that lambda maximum into T equals constant, right? So from here you can find this B, Wien's displacement constant, and that's why dimension of B is nothing but dimension of lambda, that is length, and temperature is Kelvin, you can write as K. And if you want to find the dimensional formula of the Boltzmann constant, so try to remember kinetic energy per molecule is nothing but F by 2 AT, where F is the degree of freedom, right? So per molecule is a number here, so it does not have any dimension. This left side will be kinetic energy, so M L square T minus 2. Degree of freedom is again in number, no, dimensional formula, into kb, let's say kb, into temperature is K. So from here, what is the dimensional formula of kb? You can find M L square T minus 2 K minus. You got sigma, you got kb, and you also got D, right? Now plug in this and you will get the correct answer. I think if you solve it, you will get 4 as a correct answer. Question number 10. For sound wave, if the number of notes for the fifth harmonic of an open-ended pipe is n, and that for the ninth harmonic of the same pipe with one of its end closed is n, then the ratio of n by n. So when the pipe is open, it is in the nth harmonic, which is that number of notes is, if the number of notes is fifth harmonic, so it is in the fifth harmonic. So this is in the fifth harmonic. So let's try to find the number of notes, right? It is should be n. So you know that when it is fundamental mode, there is only one note. When you go to the second harmonic, it has two notes. Third harmonic, because in the open organ pipe, all the harmonics exist. So one fundamental first harmonic, one note, second, two notes, third, three notes, and that's why in the fifth harmonic, 5 notes. That makes n equals 5. But when you close the pipe, and if you try to go for the fundamental mode, that's the first harmonic, how many notes are there? 1. And if you go to the third harmonic, this is the next level of this. So third harmonic, there are 2. Third harmonic, 2. Then if you go to the fifth harmonic, you are going to get it 1, 2, 3. And so on, right? So can you see that the number of notes is nothing but nth harmonic plus 1 divided by 2. Try to do for all, you will get the answer, right? First harmonic 1 plus 1 by 2, 1 notes. Third harmonic 3 plus 1 by 2, 2 notes. Fifth harmonic, and that's why for ninth harmonic number of notes, that is m, is nothing but 9 plus 1 by 2 equals 5. What they are asking, n by n, your answer should be 1, right? Because both are same. Next question. Two infinitely long parallel conducting wires. There are A and B, two wires, infinitely long. Okay. So this is A and this is B, right? Same direction. The wire A has uniform mass per unit length as lambda and lies on an insulated floor. So it appears that A is downside. This is A and this is B. This is lambda. This is 2 lambda. Okay. So the wire A has uniform mass per unit length lambda and lies on an insulated floor. Right. The wire B is kept fixed at a height h above the floor. So this height is h. Right. The minimum magnitude of the h so that the wire A does not rise from the floor. So you know that two parallel current carrying conductors attract each other. So this wire is trying to attract and also getting attracted. Since it has been fixed, so it cannot move. Another wire has been kept on the ground, so it can go up. So since this is attracting with certain force per unit length, there is a chance that it can go up. For not going up, you can say that this force in a critical condition should balance the weight of the weight per unit length of the wire, right? Have they given the current? So wire A, the current is I, and the wire B, current is 2I, right? So the two current carrying conductors attract each other with the force per unit length. So force per unit length is nothing but mu naught I1, I2, that will become 2I square divided by 2 pi separation between them. So this is the force per unit length due to the magnetic field. And then there is a mg, right? Mg per unit length you can find. So mg is nothing but lambda L into g, and mg upon L, that is by L. So this is the force per unit length on the wire due to the gravity. So this should be equal to how much? Lambda g, for it not getting uplifted, right? So mu naught 2I square divided by 2h should be lambda g. So from here, height, what is h? H is nothing but 2 times mu naught I square divided by how much? 2 pi lambda g. 2 mu naught I square divided by, so 2 will get cancelled, so it will become mu naught I square pi lambda g. Pi lambda g. This appears correct answer. Next is an AC voltage is given and it is applied across the series LCR circuit. Then the current amplitude is, we know that current I naught is nothing but V naught divided by Z, which gives you I naught is nothing but what is V naught? 220, and the impedance of the series RLC circuit is under root R square plus XL minus XC. XL minus XC whole square. Now put the value of omega and L and omega and C, and you find that they are getting cancelled to the calculation. So it is in the resonance, and that's why I naught is nothing but 220 divided by R. Okay. So this will become 220 divided by 100, that makes 2.2 ampere. What is omega L? Can you see the omega? In the question, this omega is the coefficient 2 to the power 3. So you can write XL is equal to omega L is nothing but 2 into 10 to the power 3. And what is the into 10 into 10 to the power minus 3. Kitna ho jayega? 20. And you know X is nothing but 1 by omega C. So it will become 1 divided by 2 into 10 to the power 3 into C is 25 micro into 10 to the power 6. So that will become 10 to the power 3 divided by 50. That again is how much? 20. And that's why XL equals XC means it is in the resonance condition. In the resonance condition, the maximum current will be maximum applied voltage divided by resistance of the resistor. So we can look at this answer. This will be answer. Question number 13. Consider a fixed uniformly charged insulating a sphere with a radius r and total charge q. So there is a sphere which is fixed. They have not mentioned solid or hollow, I think, so we can take hollow as well, as long as things are being discussed outside the sphere. Plus q, point charge minus q with a mass m is released from a distance 3r from the center. Minus q is released, right? When the point charge reaches the surface of the sphere, its speed is, you have to find the speed, you know that. When it is released, so initial speed is 0, so it is moving under the electrostatic force which is conservative in nature, that's why you can conserve the mechanical energy. So let's say this point is 1 and this point is 2, the surface. So from conservation of mechanical energy, what is the mechanical energy here? So to write the potential here, potential due to a sphere at this point, you can put all the charge at its center, so it will become K Q minus Q upon 3R is the potential energy, right? Kinetic energy is 0. When it reaches, what is the potential energy? K Q minus Q, potential is K Q upon R, so R plus kinetic energy how much? Half m into x. Okay. Now from here you can write half m v square is nothing but minus k q q, and we can remove the minus sign here. It will become k q q upon r minus k q q upon 3r. So it will become k q q upon r into 1 minus 1 by 3. And from here you can directly calculate the speed, right? So the concept involved here is that since when it is released from here, it is moving under the conservative force only. Feel free to conserve the mechanical energy. So whatever mechanical energy here, potential plus kinetic, same should be here, potential plus kinetic. This is the energy approach which always helps the student find the answer quickly. You can use the kinematics approach as well, but you can see that since the electric field intensity is varying, force will vary, right? Acceleration will vary. You will have to take the calculus into account to solve this question. So don't go for the kinematics approach, go for the inertia approach. Moving to the next question, question number 14. This question is from the photoelectric effect, right? So if you have a photo metal, so if we have a, let us say, photo metal, and then we can have a source kept at certain distance. So let's say there is a source, and this source is throwing light here, photons of certain frequency, okay, right? Certain power is being emitted which is falling on the plate, right? So that's the power falling on the plate is P, and due to these photons, the electrons are going to get ejected, so electrons are coming out, right? And that will create the photo current. So as long as frequency is greater than threshold frequency, you can expect the ejection and you can expect the photo current, right? In the question they are saying that the variation of the photo current I and the magnitude of the stopping potential with the time is best represented I. So I represents the photo current, right? And this V represents the stopping potential, right? So you can see that if power of the light source starts to decrease linearly, if the power starts decreasing linearly, area is same, the intensity will start decreasing linearly, and we know that current is directly proportional to intensity if the frequency is fixed. So, keeping the frequency fixed, right, if you start decreasing the number of photons falling on the surface, the power will start decreasing, intensity will start decreasing. So, if that is the case, the current will, the photocurrent, is going to vary linearly with the time, because the intensity is varying linearly with the time. So, you can see there is one option 1 here and there is a fourth option. Right. Next is stopping potential, right. So, what will happen if you do not change the frequency, then you can say that the maximum kinetic energy is not going to change, and if the maximum kinetic energy is not going to change, the stopping potential is not going to change, right. So, as long as frequency is constant greater than threshold frequency, the ejection will happen, maximum kinetic energy will be the same even if the less number of photons are falling, and that is why a stopping potential will not change. So, as per this logic, you should get 4 as a correct answer, not 1 as a correct answer. Okay. So, in this analysis, how did we change the power of the source? We change the power of the source by making less number of photons fall on the photometal, right. There are another ways to changing the power, right. You can move the source away from the photometal, the power will start decreasing, which is falling on the photometal. That is the another way. There is one more way to change the power or decrease the power. What will happen if I keep the number of photons falling on the photometal same, but if I change the frequency? So, let us say the frequency is decreased linearly, and a number of photons falling per second on the photometal is kept constant, and you know that energy is nothing but h times f for the single photons, it will become nhf, right. So, f is changing linearly, and that is why energy will change linearly, that is why power will change linearly, and that is why intensity will change linearly, right. So, if you can manage to do the same, which is difficult, but still theoretically if you can manage to do the same, then you are not going to get the same answer, then the fourth cannot be correct answer. What is the reason? As the frequency is decreasing, the threshold or stopping potential must decrease, because as the frequency is decreasing, ejected electron will have less kinetic energy, and that is why the stopping potential will be less. So, in that case it has to decrease. So, the stopping potential will decrease. So, the two cases are there where the stopping potential is decreasing, case 1 and case 2, right. What about the photocurrent? Since the number of photons falling are same, that is why the number of ejected electrons will be same as long as frequency is greater than threshold frequency, right. And since the number of electrons ejected are not changing, and that is why the saturation current, or you can say that the current is not going to change, in that case the current will remain constant, but the stopping potential will decrease. So, this also appear a possible answer if you make the assumption that the power is being decreased by not changing the number of photons, but by changing the frequency falling on the photometal, right. So, someone thinks in that direction might get 2 as a correct answer. Someone thinking that frequency is constant, number of photons falling per second are changing, then they will be getting this as a correct answer, right. So, to me it appears that given the logic, either you can have 2 as a correct answer or 4 as a correct answer. Now, for the 2 to be correct, this is theoretically appear to be possible, but practically it is very difficult to throw the varying frequency from a given source. But since the question is theoretical, you can assume like this and you can land on this result as well, right. So, I do not know whether this will be the bonus question or not, but theoretically it appears that it can be challenged. The next question. Two planets P1 and P2 with equal mass having radii R1 and R2 respectively with R2 equals R1 by 2. So, let us say this is R1 and this is R2. So, they are saying that R1 is 2 times R2. So, R1 equals 2 times R2. They have the same mass, equal mass, mass is m, mass is n. And then if you want to make an object escape from these planets, let us say this is V1 and this is V2, right. Escape speed does not depend on the angle of projection, right. So, once you project them, you know that V escape from a planet formula is under root gm divided by radius of the planet, right. So, since the mass is same, you can say that V escape is directly proportional to 1 by r, and that is why V2 by V1 is nothing but under root R1 by R2 is nothing but root 2 by 1, which is root 2. So, your answer should be root 2. This question is from the electrostatics. So, the unit charge, there is a charge which is taken from, initially it is at a distance 2r, right. So, there are 2 points A and B at a distance 2r and 3r, there is a very small tunnel. So, when you dig a very small tunnel in a solid charged sphere, you can assume that inside the tunnel the electric field intensity or the potential variation does not change, because it is so thin that the removal of the charges effect can be ignored, right. Now, from the center of the sphere, right. So, in this process the magnitude of the total work done on the point charge is, so you have to find the work done on the point charge in taking from where to where. The initial and the final positions are marked by A and B. This is the initial position A, this is the final position B, right. You are taking from A to B. So, since you are making it move under the conservative forces only, again you can feel free to conserve the mechanical energy, right. So, from conservation of mechanical energy, or you can also use, you can do that also, or also from work energy theorem, you know that in work power energy chapter there is a concept W external is nothing but U final minus U initial if work is done against the conservative forces only. If W external is against conservative forces only. So, in this case you can say that there is only one conservative force, that is electrostatic. So, you can use this concept, okay. And that is why W external is nothing but U at B minus U at A, which gives you W external is nothing but, to find the potential energy at B you can concentrate all the charge at its center. So, you can write K, let us say the total charge is Q, KQ upon distance is 3R, this is unit positive charge, minus initial potential energy is, find the potential due to charge a sphere at this point A, that will become KQ upon 2R into the charge itself into 1, this is the initial potential energy, right. This will become KQ upon R 1 by 3 minus 1 by 2, right. That makes W external is nothing but KQ upon R means Q divided by 4 pi epsilon naught R, 1 by 3 minus 1 by 2 will become 1 by 6 to 1 by 6. This is Q divided by 24 pi epsilon naught R. If you want to write in terms of volume charge density, so you can write Q is nothing but density into volume 4 pi by 3 into RQ into 24 pi epsilon naught R. So, this will become rho R square, this will become 72 upon 4, that will be 18 epsilon naught. So, rho r square upon 18 epsilon naught, that makes the correct answer 18. Here also we have used the concept that W external is nothing but change in potential energy if the work is done only against the conservative forces. Right. Next is 1 mole of an ideal gas undergoes a cyclic process as shown in the figure. The total heat supplied to the gas, right. Now, if you want to find the total heat supplied to the gas, then look at the process in which heat is being given to the system, right. This is asking, total heat given to the system, Q in, not Q rejected. As per the question, it appears that they are asking what is the heat supplied to the system. So, you have to identify the process in which the heat has been given to the system. Let us go from A to B. So, QAB, volume is constant, this is 2, this is 5, volume is constant but the pressure is increasing. That will happen only if you supply heat. So, heat had been supplied. So, QAB is positive, heat supplied is taken as positive. What about, not QAB, this is QDA. QDA. What is QAB? You can see that the pressure is constant but the volume is increasing. Pressure constant है, volume increase हो रहा है, it means that someone is supplying the heat to the system. That's QAB is positive. What about QBC? Volume is constant but pressure is decreasing. This happens only if the system releases energy. So, this is negative. Pressure is constant, volume is decreasing. Again, this happens only if the system is releasing energy. So, heat has been supplied only in the process D to A and A to B, right. Now, D to A is isochoric process. So, QDA is nothing but isochoric, W is 0. So, whatever delta U is, that is same as the heat supplied. So, you can write delta U, that is nothing but NCV or delta T. Okay. Similarly, QAB, isobaric process. So, you can write NCP delta T, right. So, what is net heat supplied? QDA plus QAB, which is nothing but how many mole are there? 1. So, it will become CV delta T plus CP delta T. What kind of gas it is? Monoatomic. So, CV is 3R by 2. So, 3R by 2. What is delta T? From here to here, you know that PV is equal to nRT. So, you can write TA is nothing but PV upon R. So, PA VA upon R. Similarly, TD is nothing but PD VD upon R. Use that. So, it will become PA VA upon R. So, PA into VA, that will become 600 upon R minus 100 into 2, 200 by R, that is PD into VD by R, right, plus CP will become CV plus R, 5R by 2 into this temperature minus this. So, what is TB? That will become PB VB divided by R. So, that will become 300 into 500, 300 into 5 divided by R minus again 200. So, this is 300 into 2 upon R, 300 into 2 upon R minus, this is 300. So, that will become 3 R will get cancelled. So, 3 by 2 into 600 minus 200, 400 plus 5 by 2 into 1500 minus 600, 1500 minus 600. So, this will become 900. So, this will become 600 plus 2250, that will make 26850, that is equal to 2850 joule. This much heat has been supplied. There is no such option, you can see that. So, are they asking the total heat involved in the process? So, since it is a cyclic process, so you know that delta U cyclic 0, and that is why Q is nothing but W, right, and W is the area under the curve, so is equal to area you can write this into this, right. So, this will become, so this pressure difference is 200, so 200 and volume is how much 3, that is 600 joule. So, this is the heat given minus heat ejected, right. So, that will be 600 joule. I do not know what answer to be taken. So, 600 is matching if you try to distort the question, right. Otherwise, as per the given question, the correct answer should be 2850 joule. Question number 18, straightforward, right. The uses of the microwave ultraviolet gamma rays. So, microwave waves are used to where? Warming the food, yes. Ultraviolet rays, so you can see that in the water purifier you have seen the UV are used. Gamma rays, you can kill the cancer cells, and radio waves is used in the communication. So, you can use this to solve this question number 18. Now, moving to the next question, question number 19, right. This says that a car travels on a circular racetrack of radius 50 meter, which is banked at an angle theta, and if the car travels at a speed of 10 meter per second, then the wear and tear on its tire is minimum. Taking the acceleration due to gravity 10 meter per second square, the value is theta. Now, you know that when you try to drive on a bank road, and if you are making turn, you can make the turn even if the friction is absent, right. So, for that you need to drive exactly at the banking speed, and the banking speed is under root RG tan theta, right. And on the same track, if there is a friction present, then you can have variable speed with which you can make the turn on the same radius. Look at the difference. When the track is completely smooth, there is only one speed at one radius, but when it becomes rough, you can have multiple speeds to make the turn on the same radius, right. Now, the theta is not given, and they want the life of the tire to be more, right. There should be less wear and tear. It means that you want to minimize the contact force. So, you can take the help of these concepts. On the bank road, even if the friction is not there, we can make the turn. So, try to make the turn without the help of the frictional force, only with the help of the normal reaction, and you will be having less wear and tear, right. So, let us try to find that answer. So, you know that tan theta is nothing but V square upon Rg, where R is the radius of the track, V is the banking speed, theta is the banking angle. That will become V square will become how much? 100, and Rg will become 500. That makes it 1 by 5, which makes theta equals tan inverse 1 by 5. Okay. So, that should be your answer. The next question. Okay. So, next question is from the kinematics, right, and this is the classical questions to trap the students, right. Most of the students get negative marking in such questions because they do not pay attention to the direction of the the reversing of the direction of the vehicle in one dimensional motion. So, keep this in mind. When you are traveling in a one direction, right, your motion is linear, then the magnitude of displacement is equal to distance only if you are not reversing your direction, right. But as soon as you reverse the direction of the motion on the same straight track, the displacement magnitude and distance become different, and that is why average velocity and average speed become different, right. So, in such question you have to be careful to check whether the object or the particle is reversing its direction on the straight path or not. If you can be totally satisfied that no, it has not reversed, then you can directly go for the simple approach, that is the position at t equals 6. I think they are asking for the 6, yes. What is the time interval? 0 to 6 seconds. So, find the position at t equals 6, find the position at t equals 0, take the difference in the position, that will give you the displacement. Once you get the displacement divided by the time, you will get the average velocity, which will magnitude will be same as average speed, right. So, since S equals alpha t square, what is alpha 1, so you can write as t square, put the value of beta, minus 5t, beta is 6, so minus 6t, and gamma is 5 plus 5. So, this is the position varying with time. If you want to find the velocity, so you can write velocity equals 2t minus 6. Though both are vector quantities, they have not mentioned the direction, you can write it like this also. Right. Now, we are interested in the motion between 0 to 6 seconds. So, let us see whether it has reversed the direction of its motion between 0 to 6 seconds or not. Or mind it, whenever the object reverses its direction of motion on a straight path, its velocity becomes momentarily 0. Right. So, whenever the velocity becomes momentarily 0, that is the moment when it is trying to reverse its direction. So, put the velocity equals 0 and see what time it is reversing the direction. So, v equals 2t minus 6. So, you can put 6 is equal to 0, which makes it t equals 3 seconds. Now, you understood that at t equals 3 seconds, it has reversed the direction of its motion because velocity has become momentarily 0. That is why you can't use the previous approach, otherwise you will get the wrong answer, right. So, how to solve from here? So, we know that the area under a speed time curve gives distance, and a speed is nothing but modulus of or magnitude of velocity, which is 2t minus 6. So, if you know how to draw the curve 2t minus 6, you can find the speed versus time curve it is. So, first try to find 2t minus 6, then we will take the modulus curve. So, 2t minus 6, slope is positive, right, slope is positive and the y intercept is negative. So, it will start from minus 6, and when t equals 6, it will become 6 plus 6. So, this is how it is going to look like, 6 meter per second, and this is minus 6, but a speed cannot be negative. That is why this curve, if it is velocity versus time, this is how it is going to look like, and if you want to make it a speed versus, then you will have to take the mirror image of the lower part about the time axis, and then you are done with the speed time curve. So, this is the speed time curve, right. This is the speed time curve. Now, try to find the area, and t equals 3, it has become, its speed is 0, and this is, so you can see both area are equal a, and that is why a distance equals 2a is nothing but 2 times half into base is this 3 into 6, that is 18 meter, and that is why average speed is nothing but total distance upon total time. So, 18 upon 6, that makes it 3 meter per second, right. So, you got the average speed, right. Even from the velocity time curve, you can easily find the distance. So, this is velocity, this is time, and this is the curve like this, right. This is 6, this is minus 6. So, whenever you try to find the area under the curve, you take the downward, the area below the time axis negative and above as positive, but when you are interested in distance and from the velocity time curve, you have to treat this area also as positive in order to get distance. If you want displacement, then you will have to take this negative. So, the displacement, if you look from the symmetry, is 0, but distance is nothing but 18 meter. So, this is how you can get the answer. If you want alternate approach, I can give you the alternate approach as well. Look at the alternate approach. So, we know that distance is nothing but integral speed dt 0 to t, right, and we know that our speed is magnitude of velocity, which is 2t minus 6, which is same as minus of 2t minus 6 if t is less than 3, and it will become 2t minus 6 if t is greater than 3, because when the modulus value, the inside the modulus value is negative, you can put the minus sign to remove the modulus. So, after t equals 3 seconds, this term is going to be positive, and that is why we can remove the modulus. Below 0 to 3, it is going to be negative, that is why the minus sign. So, you can write distance is nothing but integral, it will become 6 minus 2t dt 0 to 3 plus 2t minus 6 dt or 3 to 6. I hope that you know how to integrate and find the value, find the values and divide it by 6 to get the average speed. This is the alternate approach. I would not encourage you to go through this. The graphical method is the shortcut approach there, you can use that. Okay, let us move to the next question. The next question is, a point charge is placed inside a cavity. A point charge Q is placed inside a cavity of a sphere, right? Inside, consider points A, B and C as shown in the figure, where the magnitude of the electric fields are given. The points A, B and C are at the same distance from the center. So, this is the center. So, let us say this is the center C, and these are equidistant from the center, okay. And there is a charge Q here, and this is the point A here, right. If it is, let us say that it is a metallic solid sphere, I think some typo is there in the question, I think. Let us treat this to be the metal sphere, then what will happen? If you put the plus Q charge at the center, the minus Q charge will get induced here, and all the electric field from the positive charge will get trapped in the negative charges. And since this sphere is neutral, you can expect a plus Q to get induced on the outer surface, and it will get symmetrically distributed because it is not being affected by the inside electric field, they can't cross the metal, right. This is the case. So, you can see that inside there is a electric field. So, E at A is not equal to 0, and inside this charge induced and the plus Q cannot have their effect outside this metallic sphere. So, the C and B will experience the net electric field due to this, which is equidistant from their center. That is why you can say EB equals EC, right. So, this is how you can solve it. The next question. In the measurement of viscosity of liquids using the terminal velocity experiment. So, you know that whenever you try to drop a sphere in a viscous fluid, then it gains some terminal speed Vt, and if its density is sigma, it must be greater than the density of the fluid, that is rho, and you know that V terminal is nothing but 2 by 9 eta r square g into sigma minus rho, if I am not wrong, right. It means that terminal speed is directly proportional to sigma minus rho, right. Okay. So, the terminal speed will become 0 if sigma is equal to rho. So, when sigma equals rho, means sigma by rho should be 1, wherever it is 1, the terminal speed should be 0. At 1, the terminal speed should be 0, not 0 here, not 0 here, or not 0 here. So, this is the correct answer. Next, a ray of light with wavelength lambda is incident on 3 photoelectric cells. Okay. So, you know that let us photoelectric cells are lambda 1, lambda 2 and lambda 3. So, their threshold wavelengths lambda 1, lambda 2 and lambda 3. So, if some lambda is falling here, lambda, so lambda must be smaller than lambda 1 for ejection, that you should know, because as smaller the wavelength, greater is the energy associated with the photon. So, you want the wavelength of the falling photon to be less than the threshold wavelength of the photocell, right, or electric cell. Fine. So, if lambda is greater than lambda 1, no ejection. So, if lambda is greater than lambda 1, no ejection. No ejection means the stopping potential should be 0. So, V stopping equals 0. Now, look at the data. So, they are saying lambda is greater than lambda 1. So, no ejection. No ejection means V stopping 0. So, V1 should be 0. V1 should be 0. Right, and smaller the wavelength, more is the energy, kinetic energy will be more, stopping potential will be more. So, the one which has the least value of the lambda among all will require higher stopping potential. So, comparing this, lambda 2 is greater than, smaller than lambda, and lambda 3 is far greater than lambda, means here it is very much energetic, which is falling on 3. So, here the kinetic energy is maximum, and that is why stopping potential should be maximum. So, V3 should be greater than V2. So, this is wrong, this is correct. The next question. A current I0 flows through a metallic circular loop of radius r as shown in the figure. Resistance of the segment ABC is half that of the ADC. So, ADC, so let us say this is ADC, if this resistance is 2R, if this resistance is 2R, then this should be R, right. Current I0 is coming and it will try to get divided because it sees two different paths having different resistance, that is why the division will be unequal, right. And you know that the current prefers the least resistive path. So, this is the least resistive path, this is where more current will be flowing less. Since these two are in parallel, you can write I1 R1 is equal to I2 R2 and I1 plus I2 is equal to I0. If you solve this, you will get here 2 I0 upon 3 and this should be I0 upon 3. So, less resistance 2 times the current should be there, right, because it is half. So, that is correct. So, I think it is correct distribution of the current. Okay. Now, let us look at the magnetic field. You know that B is nothing but mu naught I upon 4R, that is due to the semicircle at its center. Okay. So, this one which is trying to go anti-clockwise due to which the magnetic field will be out of the plane, and due to this it is going clockwise, the magnetic field will be into the plane. Let us treat out of the plane as positive and then you will get B at O is nothing but due to this mu naught I is nothing but 2 I naught upon 3 into 4R minus mu naught I naught upon 3 into 4R, right. So, this will become B net at O is nothing but 2 mu naught I naught minus mu naught I naught, that will become mu naught I naught upon 12R. That should be your answer, 12R. 25. A particle of mass m moves along a horizontal x-axis from 0 to L. The coefficient of kinetic friction varies as a function of x. So, you can see that in this question the mu k, the surface nature has been changing as the object is moving, right. So, let us look at this surface. So, this is our surface. So, they are writing that mu k is variable, which is nothing but mu naught minus alpha x, right. And let us say this is x equals 0 origin, this is x equals L, right. A particle of mass m is moving over it. So, let us make a particle of mass m move over it, right. Now, mu naught and alpha are constant, right, they are given. The total work done by the frictional force during the motion is n times mu naught mgl, where g is the acceleration due to gravity, the value of n is, right. Okay. So, do we have the condition to find the equation exactly? So, the mu kx is this. So, they are saying mu k of L equals 0. So, exactly x equals L, the surface has become smooth. So, put it there, which makes it 0 is nothing but mu naught minus alpha L, and that makes alpha is nothing but mu naught divided by L. And from here mu k is nothing but mu naught minus, put the value of alpha, mu naught x upon L. So, this is how the mu k is changing. And then they are asking the work done by the kinetic friction. So, as long as it is moving here, the kinetic friction is acting left side to oppose the relative motion. The motion is forward. So, the angle between the force and displacement 180 degree, that makes the work done negative. There is no negative option. Are they asking magnitude? So, let us try to find the magnitude. So, we know that magnitude of the work done will be nothing but integral frictional force Fk dx, and that will go from 0 to L, right, and that is nothing but you can put the value. So, integral, this is always positive as long as x is less than L. So, you can keep it as it is. So, it will become mu naught minus mu naught x by L dx 0 to L, right. Not that, frictional force is mu times normal reaction. So, that will come this into, let me put the force, I have just put the coefficient of friction. So, this is the coefficient, and if normal reaction, if you multiply, that will become mg into dx, that is the frictional force, mu k into normal reaction, right, dx. If you integrate it, you are going to get the answer, right. Do you want me to integrate here? Let us try to do it. And that is why W is integral mg, you can take common, and then integral mu naught dx minus mu naught x by L dx, and 0 to L, 0 to L, which gives you W magnitude is mg times, this will becomes mu naught L, this will become mu naught L square by 2. So, mu naught L by 2, and that is why W is nothing but mu naught m g L by 2. So, this is what we are getting. Is there any option? Mu naught m g L by 2. Mu naught m g L by 2, mu naught m g L by 2. So, n should be 1 by 2, that makes it 1 by 2, option 3, 1 by 2. Next question. In solar system, the time period of a revolution of a planet tracing a circular orbit of radius r is proportional to, we know that Kepler's law of time period. So, T square is proportional to r cube, and that is why T is proportional to r to the power 3 by 2. This is one of the easiest question that you can find here. Okay, I think they have made some typo in making the options. So, it should be r to the power 3 by 2, maybe this 3 by 2. Moving to the next question. A solid sphere A of radius r and mass m is attached. So, if you look at this system, so there is a capital M, there is a small m, right, both are touching each other, right, their centers are being joined in this horizontal line, right, and then we have two axes, this axis as well as this axis. You have to find the moment of inertia of system about each axis, which is passing through the center of the spheres, right, and then you have to take the difference between them. So, let us try to find the moment of inertia of this case. Let us say this is IA. So, if I have to find IA, so since the axis is passing through its center of mass, the capital one, so can I write of this sphere 2 by 5 m, if the radius is capital R, r square, right. And if I have to write for this, so first I will write about its own center of mass, that will become 2 by 5 m r square, and then I can use the parallel axis theorem, plus m into r plus small r whole square. Okay. Similarly, if you want to write IB, it is passing through the center of mass of the smaller sphere, you can write, so the smaller sphere moment of inertia will become 2 by 5 m r square. For this, first find about this axis, that will become 2 by 5 m r square, and then use the parallel axis theorem. So, that will become capital M into r plus small r whole square. Correct. So, we have got IA and IB, you want IA minus IB. So, IA minus IB, if you do, I think these two terms are common, they are going to get cancelled, and then it will become a small m minus capital M into r plus a small r whole square. This appears to be the correct answer. The next question, right. So, this is from the combination of lens, right. So, first there is a convex, then there is a concave, right, and after the two successive refraction you have to find the final position of the image. So, forget about the lens 2, let us try to focus on the lens 1, right. Imagine that had the lens 2 not been there, where would have been the image. So, for the lens 1, so for L1, what is U? Object distance is, real object distance is always negative, minus 30, and what is F? So, this is a convex, the F should be positive, how much? Plus 10, 10. Use the lens formula. So, we know that 1 by V minus 1 by U equals 1 by F, which makes 1 by V plus 1 by 30 equals 1 by 10, which makes 1 by V equals, you can take the LCM, 30. So, this gives you 1 by V equals 1 by 10 minus 1 by 30, LCM will become 30, 3 minus 1, and V becomes, I think, 15 centimeter. So, if the L2 is not there, you can expect the first image to be here, I1, right. So, this is 15 centimeter. So, for this lens, what is the distance, object distance? So, that will become 15 minus 2 or 12 centimeter. I am treating this direction as the positive direction because this is the incident ray direction. So, for the lens 2, what is U? Positive, how much? 12 centimeter. What is the focal length? Negative, how much? Minus 10 centimeter. Use the lens formula. So, 1 by V minus 1 by E equals 1 by F, which gives you 1 by V minus 1 by 12 equals minus 1 by 10, which gives you 1 by V equals 1 by 12 minus 1 by 10. You can take the LCM, that will become 60, 5 minus 6, that makes V equals minus 60 centimeter. So, minus 60 centimeter from here will go back somewhere here. So, this is the I2. So, the image is, the second image is getting formed at a distance of 60 centimeter in the left of the lens 2. Look at such an option. 60 centimeter to the right, not possible, or 60 centimeter to the left of the convex lens, that should be your correct answer. Or 29. So, this is a Zener diode with a breakdown voltage of 3 volts, and this I think is 5 volt. So, since this is having more voltage potential difference than this breakdown, it is going to break down, and then it will have constant voltage of 3 volt. Then they are asking the magnitude of voltage difference between the points B and A. So, use the Kirchhoff's voltage law, whatever the battery potential difference is being provided, that will be the sum of the potential difference across each element. So, that should be 2 volt. So, this should be 2 volt. So, this is the capacitor combinations, right. So, all the capacitors are identical. So, let us say this is a C. So, this is also C, this is also C, right. if the energy stored in the capacitor P is P and total energy stored in the system are UP and UP. So, let us say here the energy is UP and the total system is UT, right. Then UP upon UT is. So, if this is V, this is also V, this potential difference is V. Here there will be equal drop, so this will become V by 2, V by 2. So, once we know the capacitance and potential difference, you can find the potential energy of the stored potential energy in any capacitor. So, you can write UT is nothing but, in this will become half into C into V square. So, V by 2 whole square is V square by 4 plus same here half C V square by 4 plus half C V square which gives you U total is nothing but, so this will become a V square by half C V square by 8, V square by 8. So, this will become C V square by 4 plus half C V square, that makes it, you can take C V square common, 1 by 4 plus 1 by 2, that LCM is 4, 1 plus 2 3. So, it will become 3 C V square upon 4. And what is UP? Half into C into V square. So, V square by 4, that will become C V square by 8, right. So, if you want UP upon UT, and that is why UP upon UT is nothing but 1 by 8 into 4 by 3, that will become 1 by 6. That should be the answer. Next question. A conducting loop of finite resistance lies in the xy plane. There is a constant magnetic field in the z direction. The area of loop varies with the time. Okay. The figure that correctly indicates the qualitative behavior of the power dissipated in the loop. So, this is the loop which resistance is constant. Resistance is finite constant, but its radius is changing, right. Area is changing. Of course, if the radius is changing, area will change, or if area changes, the radius will change, right. So, we know that when the magnetic field is constant and the area is changing, that the EMF magnitude is nothing but B into dA upon dt, right. So, B is constant, so keep it constant, and dA by dt will become A naught into cos t, right. And you know that power is nothing but E square upon resistance R. So, that will become B square A naught square cos square t upon resistance R. It means power is directly proportional to cos square t. So, look at the function cos square t. So, t is equal to 0, it should be 1 maximum. That appears to be the correct answer. Question number 32, right. Now, if you look at this question, it is saying that these two resistors are connected in series, these two are connected in parallel. One has the positive coefficient of thermal expansion and another has the negative one. Means when you are increasing the temperature, when you are heating the resistors, one is increasing its resistance, another is decreasing its resistance, right. So, if you look at the series connection, can you see that whenever you are trying to find the R equivalent in series, it will become R1 plus R2. So, R minus will get cancelled, it will get how much? 2R now. So, since both are having equal coefficient but of negative sign, that is why with temperature their net resistance is remaining constant. So, no matter how much temperature you increase or decrease, for this series combination the equivalent is always going to be 2R naught, right. So, in this case the current will be nothing but V upon 2 R naught, right. So, this is IA, which is remaining constant. So, IA remains constant, there is one option. In the B, let us try to see it. So, here it is increasing, here it is decreasing, both are in parallel. So, in parallel whenever you add two resistors like 3 ohm and let us say 6 ohm, 3 ohm, then you know the R equivalent, R1 R2 divided by R1 plus R2, that will be 18 upon 9, 2 ohm. So, if you look at the equivalent, it is smaller than the smallest resistor in connection, right. So, 2 ohm. So, when this is decreasing, so let us say sometime it was 4, it will become 3 and the equivalent will go further below 3 if it is the least one, right. So, what is happening? This one is decreasing, as it is decreasing the equivalent will become smaller and smaller, that will make the current increase, that is why this should IB should increase. So, IA remains constant and IB increases. Keep in mind, a smaller resistance it becomes, the effective goes even smaller, and that is where the current will increase. The next question. This is the collision problem with the simple pendulum oscillation, right. So, if you look at this, this is mass m, this is also mass m. This is moving with 10 meter per second and it is having perfectly elastic collision. So, for two equal mass having perfectly elastic collision, they exchange their velocity. So, it is at rest, this is at 10. So, after hitting, what is going to happen? This pendulum is going to get the speed of A and A will fall down. So, this will is going 10 meter per second. The string length is 10 meter. So, in a vertical circular motion, you should know that if you want the complete oscillations, V minimum at bottom, that result you should remember, it is under root 5 Rg, right. So, what is under root 5 Rg here? So, R is 10, this is 50, 550, 500. So, this will become 500, which is far greater than this 10 meter per second, right, and that is why it is not going to perform the complete vertical oscillation. Can it reach here? So, when you give the speed here under root 3 Rg and then it can reach here, right. So, to reach here also it requires more than a 10 meter per second. It means that it is going to oscillate like this only, it will oscillate. So, if you do the basic calculation, you will find that it is going to oscillate. If it goes beyond this, right, then the question is going to be very tough for the NEET from the NEET perspective. So, it is going to oscillate here. So, when it oscillates at the maximum height, this h, the speed will become 0 here and the amplitude, so V is equal to 0. So, all the kinetic energy will get transformed to the potential energy. So, you can write half into m into V square is 100 is nothing but mgh h, and that makes h is nothing but 50 divided by g 10, that is 5 meter. So, your answer should be 5 meter. Question number 34. A cylindrical cork of uniform density floats in a liquid of density rho 1. If the cork is displaced slightly and release, its oscillates harmonically with the time period of this much. If the same cork floats in another liquid of density rho 2, then the similar oscillation has the time period of T2t, the value of rho 2 by rho 1. So, you have to understand the oscillation of the cylinder in a non-viscous fluid, ideal fluid. So, if you want to make it oscillate, first it must float. So, you take a cylinder, immerse in, let us say its density is sigma and the density of the fluid is rho. So, if sigma is less than rho, it is going to float, and if you try to push it down a little bit, so what happens, the mg is still same, the total downward pull is still same, but due to more displacement of the liquid, the upward buoyancy increases, and that is why when you remove it, the extra buoyancy will take it up. Or even if you try to pull it up, the mg is still same, but the buoyancy force has decreased, that is why as soon as you leave it, this gravitational force dominates and pulls it down and it just starts oscillating. So, any object floating partially in a ideal fluid is going to oscillate if you try to disturb it from its equilibrium, right. So, let us say this is the equilibrium, it is at rest. I want to displace it slightly by a distance y. So, whatever volume is there in this region, the weight of that liquid will be the additional buoyancy which is going to push it up once you remove the external force. So what is the F restoring? So what is the mass here? Rho into, let's say area is A, rho into A into Y is the mass, right? So this is the mass of the fluid displaced into G, that is the weight of the fluid displaced. This is the restoring force, that is nothing but m into omega square into y, linear SHN, which makes you rho A G is nothing but y will get cancelled. M is nothing but sigma into A into, let's say total height is h, total height is h, so it will become h into omega square, and that makes you omega is nothing but under root, area will also get cancelled, it will become rho upon sigma into G upon h. So can you see that W is directly proportional to the density of the fluid. G is constant, material is fixed, so sigma is constant, fixed height is constant. So W is directly proportional to rho, and that's why time period is inversely proportional to 1 by under root, right? And that's why T1 upon T2 is nothing but under root rho 2 upon rho 1. What is T1 upon T2? So T1 upon T2 is 1 by 2, because initially it is T, this will become 1 by 2 is nothing but under root rho 2 upon rho 1, and that's why rho 2 upon rho 1 is 1 by 4. 1 by 4 should be the correct answer. Next question. The mean free path of molecules in an ideal gas A is half that of the another ideal gas P. So do you know the formula of mean free path? So I think lambda is 1 by under root 2 pi n into d square. D is the diameter, n is the number density of the gas molecules. Okay. If number density of the gases are Na and A and B, then the correct option is, okay. So they are saying the mean free path of molecules of an ideal gas A is half. So lambda A upon lambda B is nothing but half of the ideal gas B, right. So it will become 1 by 2. The diameter of the sphere of molecules of gas A is twice the diameter of this. So if you try to find lambda A upon lambda B, that will become NB dB square divided by NA into a dA square, okay, because it is inversely proportional. So lambda A upon lambda B will become NB dB square upon this, which makes you 1 by 2 is nothing but, what about diameters? So diameter, the diameter of a spherical molecule of gas A is twice, so dA is 2 times this, so this will become a square 1 by 4. So 1 by 4 into NB upon NA. So if you solve this, NB is nothing but 2 times NA. This is what is coming. So NB is 2 times NA, that should be your answer. Fine, let us move to the next question. So this is the nuclear reaction. Yes, this uranium is getting converted into thorium and helium, right. The masses are given, right, and you have to find the Q value, right. So you know that Q value is defined as mass of reactant minus mass of product into C square, right, and this is how you can get the Q value, right. In this case, let us try to find the mass defect. Mass defect. So what is mass defect? Mass of the uranium minus mass of these two, that will become, put the values, delta M is nothing but, this will become 238.050 minus this mass will become 234.043, and this mass is plus 4.003. Okay. and you will get this delta m in AMU, atomic mass unit, right. And they say that for one AMU loss or mass defect, what is the energy released? That is, for one atomic mass unit, that is 931.5 into 10 to the power 3 kilo electron volt. I have converted mega into kilo. So, find this delta m and multiply by this, you will get the energy released in kilo electron volt. Now, look at this question. Consider a long solenoid. So, whenever you take a long solenoid, you can assume that inside it the uniform magnetic field exists, right. And if you try to find the self inductance, the value comes to be mu naught n square into area into L. So, this is the length, area is A, small n is the number of turns per unit length. Okay. Now, what is the radius r? So, area can be L is nothing but mu naught n square pi r square is the area into L. See which one is matching with this. So, mu naught n square pi r square L, I think this is matching, that should be your answer. Which of the following measurements require index correction, right. So, the index correction generally is used for all the experiments which are done on the optical benches, right. So, the measurement of the focal length using the optical bench. So, you can use this 2 as a correct answer. 39. The temperature of two metallic spheres of radius r is increased by amount delta T. If the linear coefficient of thermal expansion is this much, the approximate increase in the volume of a sphere is. It should be temperature of a metallic sphere, right. So, if you are changing the temperature by delta T, they are asking the approximate increase in the volume. So, let us say we have a sphere of radius r. So, you know that volume is nothing but 4 pi by 3 r cube, right. And if you try to heat it, the radius is going to change. So, we will change the volume. So, for a very small change, you can write delta V upon V is nothing but 3 times delta R upon R, which makes delta V upon V is nothing but 3 times delta R is R alpha delta T upon R. It will get cancelled, which makes delta V is nothing but 3 alpha delta T into volume, and volume is how much? 4 pi by 3 into R cube. 3 will get cancelled, and that is why delta V is will become 4 pi R cube alpha delta T. 4 pi R cube alpha delta T. This question, a photon and an electron each of 20 electron volt energy. So, a photon has the same energy that of one electron. This is the electron, this is photon, right. So, this is the energy E, this is also having energy E. So, if you know the energy of a photon, you can find its linear momentum, that is nothing but E by C. And if you know the energy of a particle, you can write its linear momentum under root 2 m times kinetic energy, that is again E, mass of the electron. Okay. What they are asking? The ratio of photon, this momentum of the electron to the linear momentum of the photon, and this is P photon and this is P electron, and that is why P electron upon P photon, that will be P electron value is under root 2 mass of the electron into E divided by E into C, that will become under root 2 mass of the electron upon E into C. Mass of the electron is given, mass of this, the speed is given, right, and if you put the values, you will get the answer, right. So, if you by putting the value, I think you are going to get 225. So, that should be your answer. Next question, Consider that an electron is revolving in an excited state of a hydrogen atom with a velocity this much. The radius of the orbit is this much, the value of x is, right. I am going to give you some approximated process to get the answer. So, what you can do here, we know that from the atomic structure chapter that Vn is nothing but 2.18 into 10 to the power 6 z by n. So, speed is proportional to z by n, and we also know that radius is proportional to 0.53 angstrom, right, into n square by z. They have given the speed, so you can find 25.6 into 10 to the power 5 is nothing but 2.18 into 10 to the power 6, z is 1 for the hydrogen, n is n, right. Try to solve this, that will become under 25.6 to approximate. If you do it, you will get 5 and the by 10 is nothing but 2.18 by n. Solve it, n will become approximately 4, right. So, you can say that it is in the 4th orbit. So, when it is in the 4th orbit, what is the radius? 0.53, convert it into the meter. What the radius of the orbit is in the meter. So, 2.53 into 10 to the power minus 10 meter into n square will become 16 and z is 1, right. So, if you try to solve it, that will come approximately 0.9 into 10 to the power minus 9. So, it is approximately 1 into 10 to the power minus 9. This is what you are going to get. So, your answer should be 1. Right. You can also use the basic approach, writing the formula of the centripetal force, conservation of angular momentum, and then you can say that mv square by r is nothing but it is provided by electrostatic force of attraction. From there you can also derive it. The next question. So, there are two inductors identical, right. One is here, they are in series, they are in parallel, you have to ignore the mutual inductance, right. And then they are asking the ratio of EP upon EQ. What is EP? So, look at this. The induced EMF between points A and B. So, this is the point A and B, right, for configuration P. So, this is EP. That will be nothing but, so since there is only one inductor here, across this it is being asked. So, let us say L is, I am trying to find the magnitude. So, L into dit upon dt, right. And if you want to find EQ, so this L and L are in parallel, so their effective will become L by 2 into again di upon dt. This will get cancelled, L divided by L by 2 will become 2:1. So, our answer should be 2:1. Next question. In an adiabatic expansion, the temperature of 1 mole of an ideal gas decreases from this to this, the work done. We know that work done in adiabatic process is nR T1 minus T2 divided by gamma minus 1, where T1 is the initial, T2 is the final temperature. How many moles are there? 1 mole. So, 1, R is 8.3, T1 is 60 minus 50 will be 10 divided by Cp upon Cv. How much is that? 5 by 3, 5 by 3 minus 1. So, it will become 83 into 3 divided by 2, right. You solve this, I think you will get approximately this value, right, 83 into 1.5, more than 120. This question. So, water flows in a streamline motion through a horizontal pipe. You can see this pipe has variable cross sectional area. So, you know that this area is less than this area. So, you can say this is V2, let us say this is V1. You know that V2 should be greater than V1 because here area is less, right, and that is why the flow will become fast. And let us say the pressure is P1, here the pressure is P2. You should know that P1 is greater than P2 because at a smaller speed the pressure is more, right. And since they are at the both level, use the Bernoulli's equation. So, using Bernoulli's theorem, what you can say? P1 plus half rho V1 square is nothing but P2 plus half rho V2 square, which makes P1 minus P2 is nothing but half rho V2 square minus V1 square, which makes P1 minus P2 is this given. The difference, the pressure difference of water between P and Q is 15 Newton per meter square. So, this is in the SI unit, so you can write 15 is nothing but rho by 2 will become 500, rho is 1000 kilogram per meter cube, and that will make V2 square minus V1 square. So, from here you can write V2 square minus V1 square is nothing but 15 upon 500. This is same as 3 upon 100. Okay. And also A1 V1 equals A2 V2, equation of continuity. A1 V1 equals A2 V2, that makes V2 is nothing but A1 by A2 into V1, right. So, that makes V2 is A1 by A2, so it will become A1 by A2 into V1 square minus V1 square is nothing but 3 by 100. That makes what is A1 by A2. So, one area is the area of cross section at P, that is A1, that A1 is 40 and 20. So, A1 is 40 and A2 is 20. So, it will become 2. So, it will become 4 into V2 square, this was V1, yes, V1 square. So, 4 into 4 V1 square minus V1 square, and if you solve it, 3 V1 square equals 3 by 100, and that is why V1 equals 1 by 10. 1 by 10. Okay. Once we get V1, we have to find the rate of flow, right. So, they are asking the rate of flow of water is. So, you know that the volume rate of flow is A1 V1. So, that is why A1 V1 is nothing but what is A1? A1 is 40, right, and this is meter per second, that will become 10 centimeter per second. So, you want the answer in cc, so you can find it 40 into 10, this is already 40 centimeter square, that will become how much? 400, right. So, that will be 400 centimeter cube per second, cc per second, that should be your answer. Coming to the last question, a thin horizontal disc is rotating about a vertical axis passing through its fixed point O. Its angular momentum LA and LB computed about points A and B respectively, with OB equals 2 times OA. So, this is rotating about this axis. Is it a disc? Yes, it is a disc, right. You want to find the angular momentum. You know that for the combined motion, angular momentum L is nothing but m into V center of mass. Let me write it by giving the diagram. So, let us say we have a particle of mass m, center of mass is this, and this is the point A. I want to write the angular momentum about A. So, I will just look at its path, I will draw perpendicular, this is R perpendicular. So, we write it as L about A is nothing but L due to translation plus L due to rotation. So, L about A is nothing but due to translation linear momentum m into V center of mass into R perpendicular, and about due to rotation I about center of mass into omega, right. You can see in this question the V center of mass is 0. So, due to translation about any point it is going to be 0. So, about A as well as about B there is no angular momentum due to translational motion, only due to rotational, which is I about center of mass into omega. So, it will be same whether it is point A or point B, and that is why L about A is same as L about B, and your answer should be 1, right. I hope you understood the solutions of these questions. Thank you.